June 6, 1944, 6:31 a.m. Omaha Beach, Normandy. The water is red. Not metaphorically, not in memory's distortion, but literally red, dyed crimson by blood that pours from men cut apart by German machine gun fire before they reach the sand. Landing craft, vehicle, personnel, LCVPs in military designation, Higgins boats to the men who ride them, grind against the beach obstacles, their steel ramps dropping into waist-deep water that has become an abattoir. The sound is unbearable, the metallic shriek of bullets striking hull plating, the screams of wounded men, the deeper concussive thunder of German artillery shells bracketing the landing craft as they attempt to withdraw. Coxswains struggle to reverse their vessels off the beach, engines roaring, propellers churning sand and blood, while the hulls, thin steel plates riveted to welded frames, begin to fail. Not from direct hits alone, though those are devastating, but from something more insidious. The hulls are cracking along their seams, splitting where steel meets steel, where the welds that hold these craft together are proving inadequate to the stress of combat operations in heavy seas against fortified beaches. 300 yards offshore, aboard the USS Samuel Chase, Chief Petty Officer Vincent Lombardi watches through binoculars as another LCVP founders. Its hull breached, its ramp jammed by battle damage, 36 soldiers trapped aboard a vessel that is rapidly becoming a coffin. Lombardi is 34 years old, a Navy welder from Philadelphia, who has spent the previous 18 months in England, overseeing the repair and maintenance of the invasion fleet's landing craft. He has warned about this. For months, he has documented hull failures, catalogued stress fractures, filed reports, noting that the welding specifications used in landing craft construction are inadequate for the operational demands of amphibious assault. His warnings have been received with the institutional skepticism that militaries reserve for junior personnel who claim to have discovered fundamental problems in equipment that thousands of engineers have approved. Now, watching men die in vessels whose hulls are failing exactly as he predicted, Lombardi feels a rage so pure it transcends emotion and becomes something closer to physics, a force demanding action, demanding solution, demanding that he fix what incompetence and bureaucracy have broken. The landing craft hulls are failing because their welds are brittle, because the steel specifications prioritize ease of construction over durability, because peacetime engineering standards have been applied to equipment that must survive the ultimate stress test of combat. And Lombardi, standing on the deck of a transport ship while the largest amphibious invasion in history threatens to founder on a beach in France, knows how to fix it. The knowledge sits in his mind with absolute clarity: a different welding technique, a modified steel treatment, a procedural change that could be implemented immediately using equipment already available aboard the repair ships supporting the invasion fleet. The problem is that implementing this fix requires violating Navy welding specifications, contradicting the technical manuals written by metallurgical engineers in Washington, and taking personal responsibility for modifications that, if they fail, will result in court-martial and the deaths of however many men ride in the modified craft. The problem is that Vincent Lombardi is a chief petty officer, not an engineer, not an officer authorized to approve equipment modifications, not anyone whose opinion on metallurgical specifications should matter to the vast military apparatus prosecuting the invasion of Hitler's fortress Europe. The problem, Lombardi decides in the seconds it takes for another landing craft to beach itself and discharge its human cargo into German fire, is one he will solve regardless of authorization, regardless of consequences, regardless of what the manuals say is proper procedure. Because proper procedure is killing men, and Vincent Lombardi knows how to weld steel in ways that proper procedure has not imagined. The landing craft that carried Allied forces ashore on D-Day were, in their conception and mass production, quintessentially American achievements, vessels designed for a single purpose, manufactured in enormous quantities, adequate rather than excellent, but available in numbers that overwhelmed qualitative deficiencies. The primary design, Andrew Higgins LCVP, could carry 36 troops or a jeep and 12 men, drew only 3 feet of water, and could be produced rapidly using semi-skilled labor and standardized components. Between 1942 and 1945, American shipyards manufactured over 23,000 LCVPs, along with thousands of larger landing craft in various configurations. This industrial achievement came at a cost. The pace of production precluded extensive testing under combat conditions. The steel specifications, welding procedures and construction techniques were optimized for manufacturing speed and cost rather than operational durability. Navy inspectors checked for gross defects but lacked time for the kind of stress testing that might reveal weaknesses, emerging only under sustained combat operations. The result was a fleet of landing craft that worked adequately in training exercises, short runs in calm waters, controlled beaches, minimal stress on hull structures, but that began failing when subjected to the brutal reality of contested amphibious landings. The failures manifested as cracks in hull plating adjacent to weld seams, particularly along the keel and at stress points where the flat bottom transitioned to angled sides. The welds themselves often held, but the steel immediately beside them fractured, a phenomenon called heat-affected zone cracking that occurs when welding processes alter the metallurgical properties of base metal, making it brittle. In calm conditions, these cracks were minor nuisances requiring dockyard repair. In combat conditions, with landing craft repeatedly beaching at high speed, backing off under power, taking on water from near misses, and operating continuously for hours, the cracks propagated catastrophically. Hulls split open, craft flooded and sank. Men drowned or were forced to swim through fire-swept waters, because the vessels meant to deliver them safely ashore had literally broken apart. Vincent Lombardi had begun documenting these failures in late 1943, during the intensive training exercises preceding D-Day. He was not investigating welding defects systematically that would have required authority he did not possess. He was simply repairing landing craft as they returned from exercises, and he noticed patterns. Certain vessels developed cracks repeatedly in identical locations. Repairs using standard welding procedures held temporarily but failed again under stress. The fractures occurred not in the welds but adjacent to them, suggesting that the welding process itself was damaging the steel. Lombardi had worked as a shipyard welder in Philadelphia before the war, employed in commercial shipbuilding where profit margins were thin and quality control was paramount, because failures meant lawsuits and bankruptcy. He had learned, through practical experience and the informal mentorship of older welders, techniques that Navy manuals did not include: preheating base metal before welding to reduce thermal shock, using specific electrode types that produced more ductile welds, controlling cooling rates to prevent brittleness. These techniques were slower and required greater skill than standard Navy procedures, which prioritized speed and simplicity to accommodate the semi-skilled welders who comprised most of the workforce. In his repair work, Lombardi began experimenting. On craft that returned repeatedly with cracks, he would grind out not just the damaged area but a broader zone around it, preheat the steel with a torch, weld using low-hydrogen electrodes that produced tougher welds, and then allow the repair to cool slowly under insulating blankets. These repairs held. The same vessels that had been chronic problems stopped returning for the same failures. Other welders in his repair section noticed and began adopting his techniques, even though they violated the standard procedures Navy inspectors expected to see. Lombardi documented his methods and their results, compiling a file that included photographs of failed welds, metallurgical explanations written in the careful hand of someone self-taught in technical matters, and comparative data showing that his modified procedures produced dramatically more durable repairs. He submitted this documentation through his chain of command in February 1944, with a recommendation that landing craft construction specifications be modified to incorporate improved welding procedures. The response, when it came 6 weeks later, was bureaucratically elegant and operationally useless. Engineers at the Bureau of Ships acknowledged that heat-affected zone cracking was a known issue in welded steel construction and noted that field modifications to approved welding procedures are not authorized without formal metallurgical testing and Bureau approval. The recommendation was denied. Landing craft would continue to be built and repaired using existing specifications, Chief Petty Officer Lombardi was reminded that deviation from approved procedures could result in disciplinary action. This decision was not irrational within the logic of large military bureaucracies. Welding specifications existed for reasons. They had been developed by competent engineers. They ensured standardization across thousands of welders. They facilitated quality control by inspectors who checked for compliance with documented procedures. Authorizing field modifications based on one welder's observations risked fragmenting the entire system, creating inconsistencies, and potentially introducing worse problems than those being solved. From the Bureau's perspective, landing craft were performing adequately in training exercises, production rates were meeting schedules, and there was no crisis demanding immediate procedural changes. From Vincent Lombardi's perspective, standing on the deck of the Samuel Chase watching landing craft crack open and sink while carrying men to their deaths, the Bureau's logic was an obscenity that prioritized process over human life. At 9:15 a.m. on June 6, with Omaha Beach still contested and casualties mounting, Lombardi approached Commander Howard Vickery, the senior naval officer responsible for landing craft operations from the Samuel Chase. Vickery was coordinating the desperate effort to maintain the flow of reinforcements and supplies to the beach, despite heavy losses in landing craft by mid-morning. Over 30 LCVPs had been disabled or destroyed, most through battle damage, but several from catastrophic hull failures of the type Lombardi had warned about. Lombardi requested authorization to begin immediate modifications to the landing craft fleet using his improved welding procedures. The request was bold to the point of insubordination, a chief petty officer asking a commander to authorize widespread violation of Navy technical specifications during the largest military operation in history, based on techniques that had been explicitly rejected by the Bureau of Ships. Vickery's response was pragmatic. He lacked authority to approve such modifications, but he also lacked the landing craft to sustain operations if hull failures continued at current rates. He told Lombardi that he could not officially authorize anything, but that if Lombardi wanted to conduct emergency repairs using whatever procedures he thought necessary, Vickery would ensure that Navy inspectors did not interfere. It was authorization by omission, deniability by implication, and exactly the permission Lombardi needed. By noon, Lombardi had organized every welder in the repair section, 19 men, into teams working on landing craft that had returned from the beach with minor damage or mechanical problems. The standard repair procedure was to patch holes, re-weld cracked seams using conventional techniques, and return the craft to service as quickly as possible. Lombardi's procedure was different and dramatically slower. Each craft received a comprehensive inspection for hairline cracks in the hull plating. Any crack, however minor, was ground out completely along with a 6-inch margin of surrounding material. The entire area was then preheated to 300 degrees Fahrenheit using torches. Welding was performed using low-hydrogen electrodes, E7018 in welding nomenclature, which produced stronger, more ductile welds than the standard E6010 electrodes. After welding, the repair area was covered with thermal blankets and allowed to cool slowly over 30 minutes, preventing the rapid cooling that caused brittleness. The procedure increased repair time from approximately 90 minutes per vessel to nearly 4 hours. It consumed electrodes at twice the standard rate. It required more skilled welding, more careful inspection, more time when time was the scarcest resource in the entire operation. It also worked. Landing craft that received Lombardi's modifications returned from subsequent runs without developing new cracks. Hull failures among modified craft dropped to near zero. Word spread through the invasion fleet with the speed that attends solutions to desperate problems. Other repair ships requested that Lombardi provide welders to train their crews in the modified procedures. By June 8, 73 landing craft had received comprehensive modifications. By June 10, over 200. By the end of June, virtually every LCVP supporting the Normandy beachhead had been re-welded using Lombardi's techniques, and the hull failure rate had declined from roughly 8% of craft per week to less than 1%. The impact on operational capability was immediate and substantial. Landing craft were the critical logistics bottleneck in the Normandy campaign. Everything that sustained Allied forces ashore, from ammunition to medical supplies to reinforcements, moved across the beaches in these vessels. Losing even a small percentage to hull failures compounded the losses from enemy action and created shortfalls that threatened the entire operation. General Omar Bradley, commanding U.S. ground forces, later wrote that the shortage of landing craft in the first 10 days after D-Day was the single most critical logistics constraint we faced. We had troops waiting to land, supplies stacking up on ships offshore, and insufficient craft to move them to the beach rapidly enough. Lombardi's modifications did not solve the landing craft shortage that required additional vessels, better beach organization, and reduced German resistance, but the modifications prevented the shortage from becoming catastrophic. Craft that would have failed and been lost instead remained operational. Crews developed confidence that their vessels would not break apart underneath them. The psychological impact was substantial. Coxswains who had been approaching beaches with understandable terror, knowing their craft might split open at any moment, regained operational effectiveness when that particular terror was eliminated. German defenders noticed the change without understanding its source. Interrogation reports from captured German soldiers include references to American landing craft that seemed more robust in the second week, and that withstood grounding and obstacle impact better than initially observed. Some German officers theorized that the Americans had brought newer, better-built craft into service. None imagined that virtually the entire landing craft fleet had been comprehensively re-welded using unauthorized procedures by repair crews working around the clock, led by a chief petty officer whose recommended modifications had been rejected by his own service's engineering bureau. For Lombardi and his repair crews, the work was exhausting beyond any civilian experience. Welders worked 18-hour shifts, ate cold rations while waiting for steel to preheat, slept in brief snatches between vessels. The physical toll was severe, welding for extended periods in the confined spaces of landing craft hulls, breathing fumes, working in heat that made the English Channel's dampness feel like a sauna. Several welders suffered heat exhaustion. Others developed respiratory problems from prolonged fume exposure. All understood that stopping meant men would die in craft that could have been saved, and so they did not stop. The sound that dominated this work, that echoed across the anchorage where repair ships clustered, was the sharp crackling hiss of arc welding, electricity jumping through ionized gas, melting steel, depositing filler metal into joints that would carry men through the surf and onto hostile beaches. It was an industrial sound, harsh and unmusical, the sound of fabrication and repair, of metal being joined at the molecular level through heat and electric current. To the men waiting to board landing craft for subsequent assault waves, that crackling hiss became a sound of confidence. It meant someone was fixing things, improving things, making the vessels safer. It meant that the institution, however slowly and imperfectly, was responding to the realities of combat. The welding arc's crackling became, in the weeks following D-Day, a symbol of American industrial adaptability, the capacity to identify problems, develop solutions, and implement them rapidly at the tactical level, without waiting for strategic-level authorization. This adaptability was not unique to Lombardi or to landing craft repair. It characterized American operations throughout the Normandy campaign and the broader war. Tank crews welded improvised armor to their Shermans. Engineers developed specialized equipment for breaching obstacles. Artillery units modified firing procedures to increase effectiveness. Infantry devised new tactics for hedgerow fighting. These innovations emerged from the bottom up, from soldiers and junior officers and NCOs who encountered problems and solved them using whatever resources and authority they possessed. The contrast with German operational patterns was instructive. The Wehrmacht was a formidable military machine, tactically sophisticated and operationally flexible within the boundaries of established doctrine. But German military culture was more hierarchical, more dependent on formal authorization for equipment modifications and procedural changes. German soldiers who identified equipment deficiencies reported them through channels and waited for solutions to arrive from above. This created a lag between problem identification and solution implementation that American forces, with their more decentralized approach, could exploit. The welding arc symbolized this difference. It was not a weapon in any conventional sense, It did not kill enemy soldiers or destroy enemy equipment, but it sustained operations, maintained capability, and prevented friendly losses. It represented the unglamorous work of logistics and maintenance that underpinned every combat operation that made possible the dramatic achievements of armored breakouts and infantry assaults and strategic bombing campaigns. Wars are not won by logistics alone, but they are frequently lost by logistics failures, and the American capacity to solve logistics problems through decentralized innovation was a decisive advantage. For Vincent Lombardi, the welding arc was more personal. It was the tool of his trade, the instrument through which he could affect outcomes in a war that otherwise seemed beyond the influence of individual enlisted men. He could not command armies or plan strategy or make diplomatic decisions, but he could weld steel in ways that kept landing craft intact, that brought men to shore alive in vessels that did not break apart beneath them, that solved through technical expertise and physical labor a problem that bureaucracy and hierarchy had failed to address. The official recognition of Lombardi's work came slowly and incompletely. In August 1944, he received a commendation from Commander Vickery for exceptional performance of duty in support of amphibious operations. The commendation mentioned innovative repair procedures, but did not specify what those procedures were or acknowledge that they violated Navy technical specifications. The Bureau of Ships, learning belatedly about the widespread adoption of unauthorized welding procedures, initiated an investigation that concluded in early 1945. The investigation's report acknowledged that Lombardi's techniques produced superior results, but criticized the irregular manner in which they had been implemented and recommended formal procedural changes through proper channels. By the time those formal changes were approved and incorporated into Navy welding specifications in June 1945, the war in Europe had ended and landing craft were being decommissioned by the thousands. The improved procedures were applied primarily to Pacific operations, where they contributed to the success of amphibious assaults at Iwo Jima and Okinawa. Navy welders at Pearl Harbor and other Pacific bases received training in the modified techniques, often taught by instructors who had learned them from Lombardi's crews at Normandy, but who did not know the technique's origin or the irregular circumstances of their development. Lombardi himself received the Bronze Star in November 1944, presented in a brief ceremony aboard a repair ship in the English Channel. The citation noted his meritorious service, but remained vague about specifics. Secrecy restrictions prevented public acknowledgement of landing craft deficiencies, or the unauthorized nature of the modifications. He accepted the medal with characteristic modesty, deflecting credit to his repair crews and expressing frustration that the improvements had not been implemented earlier through official channels. After the war, Lombardi returned to civilian life and resumed work as a shipyard welder in Philadelphia. He gave few interviews about his military service and seemed uncomfortable with attention. When asked about the landing craft modifications, he typically described them in technical terms: preheat temperatures, electrode specifications, cooling rates, rather than discussing their operational impact or the lives they had saved. This reluctance reflected partly his personality, but also the culture of his generation and profession, men who solved problems through skilled manual labor rather than intellectual distinction, who saw their work as simply doing what needed to be done, rather than as heroic accomplishment worthy of acclaim. The broader historical narrative of D-Day and the Normandy campaign focused understandably on combat operations, the bravery of infantry assaulting fortified beaches, the tactical decisions of commanders, the strategic stakes of establishing the Second Front. The logistics and maintenance that made those operations possible received less attention, and within that already obscure domain, the contribution of a single welder who modified thousands of landing craft using unauthorized procedures was effectively invisible. Military historians who studied Normandy logistics noted the improvement in landing craft reliability after the first week, but attributed it to improved maintenance procedures or adaptation to operational conditions without investigating the specific nature of those improvements or identifying the individuals responsible for implementing them. There exists in the National Archives a photograph taken aboard a repair ship off Omaha Beach in mid-June 1944. The image shows a welder, identity unknown, working inside the hull of an LCVP, his welding arc's brilliant light casting harsh shadows across riveted steel plating. The welder's posture suggests exhaustion, shoulders hunched, body braced awkwardly in the confined space. Around him, barely visible in the photograph's darkness, are the tools of his trade: welding cables snaking across the deck, electrode holders, grinding equipment, thermal blankets for controlling cooling rates. The photograph was taken by a Navy combat photographer documenting repair operations, and it was never published. It lacked the dramatic visual appeal of combat photography, showed nothing that civilian audiences would find compelling. But the image captures something essential about the American war effort that more dramatic photographs miss. Here is unglamorous work performed in difficult conditions by skilled craftsmen whose names history would not record. Here is problem-solving at the tactical level, innovation emerging from practical necessity rather than formal planning. Here is the welding arc's crackling light, harsh, industrial, the signature of metal being joined through controlled violence, of vessels being made whole and capable, of men being given transport that would not betray them at the moment of greatest danger. The welder in that photograph might be Vincent Lombardi. The records do not specify, but whether or not the specific image captures him, it represents his work and the work of the hundreds of welders who implemented his modified procedures across the invasion fleet. It represents the thousands of hours spent in cramped, hot, dangerous conditions, joining steel to steel with precision that would determine whether men lived or died. It represents the democratic principle that expertise resides throughout a hierarchy, not just at its apex, and that solutions to complex problems often emerge from those closest to the work. The German defenders of Omaha Beach expected many things from the Allied invasion. They expected overwhelming numbers. The intelligence reports had made clear that American industrial capacity could produce forces of extraordinary size. They expected material abundance. Captured American equipment revealed a level of logistical support that German units could only imagine. They expected tactical innovation. American forces had demonstrated adaptability in North Africa and Italy. But German defenders did not expect, could not have anticipated, that the American capacity for adaptation extended down to the level of welding procedures, that when landing craft began failing, American repair crews would independently develop and implement solutions that violated their own service's technical specifications, that this would happen not through formal engineering processes, but through the initiative of enlisted technicians working without authorization because operational necessity demanded action. This oversight was not a failure of German intelligence. It reflected a deeper misunderstanding of how democratic societies prosecute industrial warfare. German military culture, for all its tactical brilliance, assumed that military effectiveness required strict hierarchy, that discipline meant compliance with orders and procedures, that innovation flowed downward from authority. American military culture, reflecting the society that produced it, was messier. Hierarchy existed, but was less absolute. Discipline coexisted with initiative, and innovation emerged from all levels, because the culture trusted individuals to exercise judgment in pursuit of mission objectives. The welding arc's crackling hiss, echoing across the anchorage off Normandy, was the sound of this cultural difference manifesting in metal. It was the sound of problems being solved outside formal channels because formal channels had failed. It was the sound of skilled craftsmen applying expertise that peacetime engineering had not captured. It was the sound of American adaptability, industrial capacity, and democratic faith in individual capability, combining to overcome deficiencies in planning and equipment. For the German soldiers dug into bunkers above Omaha Beach, watching wave after wave of landing craft discharge troops, despite heavy fire, despite casualties, despite conditions that should have paralyzed the assault, the sustained pressure was psychologically devastating. They had been told that American soldiers were soft, poorly trained, dependent on material advantages, but lacking fighting spirit. The reality contradicted this propaganda comprehensively. The Americans kept coming, kept dying, and kept advancing, not because they were superhuman, but because the vast system behind them continued functioning, despite terrible losses, continued adapting, continued finding solutions to the tactical and technical problems that emerged in combat. The landing craft whose hulls did not break apart, whose seams held under stress, whose crews delivered troops to the beach, and then successfully withdrew for the next load. These craft were not superior by design, but had been made superior by modification, by welders working through the night, to implement procedures that textbooks had not imagined necessary. This was American strength distilled to its essence. The capacity to identify what was broken and fix it, to ignore regulations when regulations produced failure, to trust that practical expertise mattered more than formal credentials. Vincent Lombardi died in 1987 at the age of 77 in Philadelphia, having spent his post-war decades working in the same shipyard where he had learned his trade before the war. His obituary in the local newspaper mentioned his military service briefly, noting that he had served in the Navy during World War II and received the Bronze Star. It made no mention of landing craft, welding modifications, or the thousands of lives that his unauthorized innovations had preserved. His family donated his medals and papers to a veterans organization, where they remain in storage, rarely examined. The landing craft he modified were scrapped in the years following the war, their steel recycled into peacetime construction, their service records lost in the vast bureaucratic archives of a military demobilizing with extraordinary speed. No examples of the modified welds survive for metallurgical study. The techniques Lombardi developed were eventually superseded by newer welding technologies, metal inert gas welding, friction stir welding, laser welding, that made his innovations obsolete. Modern naval architects designing amphibious vessels use sophisticated finite element analysis to predict stress concentrations and optimize structural designs in ways that were impossible in 1944. The problems that Lombardi solved through practical experimentation and skilled craftsmanship are now solved through computer simulation and advanced materials science. But the essential lesson of his work remains relevant. Complex organizations, whether military or civilian, develop procedures and specifications for good reasons: standardization, quality control, safety, efficiency. These procedures work well under anticipated conditions. They fail, sometimes catastrophically, when conditions deviate from those anticipated. Organizations that empower individuals to identify such failures and develop solutions, even when those solutions violate established procedures, are more resilient and more effective than organizations that demand rigid compliance with rules, regardless of circumstances. Lombardi's story exemplifies this principle in its starkest form. He identified a problem that was killing men. He developed a solution using his professional expertise. He implemented that solution despite explicit institutional prohibition, because operational necessity outweighed procedural compliance. His judgment proved correct. The modified procedures saved countless lives and sustained the logistics flow that the Normandy invasion required. Had he been wrong, had the modifications caused worse failures than those they prevented, he would have faced court-martial and potential criminal charges. He accepted that risk because the alternative, watching men die in preventable accidents while he obeyed regulations he knew were inadequate, was morally intolerable. There is a sound that veterans of the Normandy logistics operation remember, a sound that characterized the anchorages and beaches where supply operations continued day and night for weeks after D-Day. The overlapping industrial symphony of diesel engines, pumps, cranes, generators, and above all, the sharp crackling of arc welding as repair crews worked continuously to maintain the landing craft fleet. That sound, harsh, unmusical, the signature of industrial labor, was the sound of victory being built through unglamorous work, through maintenance and repair, through the accumulated effort of thousands of men whose names would never appear in newspapers, but whose work made newspaper headlines possible. The welding arc's light, painfully brilliant when seen directly, illuminated more than the steel it joined. It illuminated the essential character of the American war effort: pragmatic, adaptive, willing to discard procedures that did not work, and embrace solutions that did, regardless of their source or their compliance with peacetime standards. It illuminated the democratic principle that expertise deserves respect, regardless of rank, that a chief petty officer's practical knowledge might exceed a bureau engineer's theoretical understanding, that solutions to complex problems emerge most effectively when organizations listen to those closest to the work. For the 19-year-old soldiers who rowed Lombardi's modified landing craft to shore, who survived the journey in vessels whose hulls held together under stress that would have cracked unmodified craft, the welding that saved their lives was invisible. They never knew that the LCVP carrying them had been re-welded using unauthorized procedures, that the seams they took for granted represented a welder's refusal to accept that Navy specifications were adequate, that their survival depended partly on an enlisted man's decision to violate regulations because following regulations meant preventable deaths. This anonymity was characteristic of Lombardi's contribution, and of the contributions of thousands of support personnel whose work sustained combat operations. They performed essential functions in obscurity, solved critical problems without recognition, saved lives without acknowledgement. The narrative of war focuses naturally on combat, on moments of crisis and courage, on battles won or lost, on the dramatic confrontation of armed forces. But wars are sustained by logistics, maintenance, and the unglamorous work of keeping equipment functional and operations flowing. The welders, mechanics, supply clerks, and technicians who performed this work were not heroes in any conventional sense. They were skilled professionals solving practical problems under difficult conditions, doing what needed to be done because the mission demanded it. The arc welder's crackling hiss has been silent at Normandy for 80 years. The repair ships have long since sailed away. The beaches where landing craft grounded and discharged their human cargo are now peaceful, visited by tourists who photograph the monument and memorials without understanding the complexity of the logistics operation that sustained the campaign. Those memorials commemorate. The steel that Lombardi welded has been recycled multiple times over, its molecular structure bearing no memory of the arc's heat or the hands that guided the electrode. But the principle endures. In every complex endeavor, military or civilian, governmental or commercial, there is a gap between how procedures say things should work and how they actually work under operational stress. Organizations that bridge this gap through rigid adherence to procedure regardless of results will fail. Organizations that bridge it through adaptive innovation, through empowering individuals to identify problems and implement solutions, through valuing results over process, these organizations succeed. The American military in World War II was not free from bureaucracy, rigidity, or procedural ossification. It made countless mistakes, wasted resources, and sometimes sacrificed lives to institutional inertia. But it was, on balance, more adaptive than its enemies, more willing to empower junior personnel, more capable of rapid innovation at the tactical level. This advantage did not guarantee victory. Industrial capacity, strategic positioning, and the contributions of allies all mattered immensely. But it contributed to victory in ways that are difficult to quantify but impossible to dismiss. Vincent Lombardi, working through the night to re-weld landing craft hulls, using procedures that Navy specifications prohibited, exemplified this adaptive capacity. He was not extraordinary by birth or education. He was a skilled craftsman who understood his trade deeply, who recognized when procedures were inadequate, and who possessed the moral courage to act on that recognition, despite institutional opposition. His story represents thousands of similar stories of mechanics who modified equipment, of supply officers who improvised logistics solutions, of technicians who kept complex systems functioning under impossible conditions, of junior personnel who solved problems that senior leadership had not recognized existed. The welding arc's light, harsh, industrial, the signature of metal joining at thousands of degrees, was the light of American democracy at war, not the democracy of constitutional principles or electoral processes, though those mattered immensely, but the democracy of practical action, the faith that expertise resides throughout society, that solutions emerge from those who grapple directly with problems, that authority should enable effectiveness rather than constrain it through rigid procedure. This was not a perfect system. It produced waste, inconsistency, and occasional chaos, but it also produced Vincent Lombardi and his modified landing craft, Sergeant Cullen and his hedgerow cutters, Lieutenant Colonel Hull and his fuel management procedures, a pattern of innovation emerging from tactical necessity. implemented by individuals who understood that regulations exist to serve missions rather than missions existing to follow regulations. In the end, the story of the mad welder, whose steel trick saved thousands of landing craft, is a story about the nature of expertise and authority in democratic societies at war. Expertise without authority is frustrated. Lombardi knew how to solve the problem months before D-Day, but lacked power to implement his solution. Authority without expertise is blind. The Bureau of Ships possessed authority to set welding specifications, but lacked the practical knowledge that revealed those specifications' inadequacy. Victory required combining expertise and authority, and the mechanism for that combination was not formal procedure but operational necessity and commanders willing to trust subordinates' judgment. The crackling hiss of the welding arc, joining steel to steel in the anchorage off Omaha Beach, was the sound of that combination functioning, the sound of expertise being applied through authority borrowed or assumed, the sound of problems being solved outside formal channels because formal channels had failed, the sound of democracy defending itself through the initiative and skill of ordinary men who understood that their nation's survival depended on their willingness to act when action was required, regardless of what the regulations said was proper procedure. That sound has faded into history, but its echo remains in every organization that empowers individuals to innovate, in every institution that values results over process, in every society that trusts its citizens to exercise judgment and take responsibility. The arc welder's light illuminated more than steel seams in landing craft hulls. It illuminated a truth about how free societies wage war, and more broadly, about how they solve complex problems by distributing authority widely, by trusting expertise wherever it resides, by valuing effectiveness over orthodoxy. This was America's advantage in 1944, forged in the workshops and repair bays where skilled craftsmen worked through the night to keep the machinery of war functioning. And it remains America's advantage, tested in different contexts, but rooted in the same democratic faith, that a welder in Philadelphia might have insights that bureaucrats in Washington lack, and that when the mission demands it, the welder's insights should prevail.